Alright, so this problem. Inclined plane. That's not a projectile. Just because you see something diagonal doesn't mean you get to call it a projectile. And you've seen inclined planes before, and you've seen blocks sliding, so I don't know why people did projectile motion for this. It was completely wrong. So let's go ahead. We get v squared equals v, sorry. So we don't have time, so let's try to figure out this height that it'll rise to. So we have v squared equals v naught squared plus 2a x minus x naught. That's the equation that we have. Now the acceleration is going to be g sine theta for a block sliding up an inclined plane. We're assuming no friction, and again that works with normal, weight. We got mg cos theta and mg sine theta here. So that's what's going on here. So that's like negative g sine theta. So we have we launch at a speed v naught. So we at the top we reach 0 for our speed. We launched with the speed v naught minus 2g, right? Now x. Let's be clear. This is h, and this is the actual distance we cover. So we know h over L equals sine theta. So the L that we cover is h over sine theta. So this is going to be 2g sine theta times h over sine theta. These end up canceling, and so we're going to end up getting that, this means that we're going to end up getting that h is v naught squared over 2g. Now, let's assume that we had a coefficient of friction and that things were rough. So similar equation, we'll have 0 squared equals v naught squared minus 2. We're getting an acceleration here in a second. This is still h over sine theta here. But now let's take a look at what our acceleration will be. So if we've got friction acting this way, fighting the upward motion, we're going to have mu mg cos theta plus mg sine theta, okay, as the force dragging the block down. So what we end up getting for our acceleration is that the acceleration is the following: mu g cos theta plus g sine theta. So our height ends up being v naught squared sine of theta over mu g cos theta plus g sine theta. The time it takes the block to get up to that height, well, we can say that v equals at plus v naught. So 0 equals negative mu g cosine theta plus g sine theta times t plus v naught. So the time is going to end up being v naught over mu g cos theta plus g sine theta. Now the time it takes the block to return to the bottom of the incline and its speed. So here we go. The acceleration down the inclined plane is going to be g sine theta minus mu g cos theta. I'm going to leave you to figure that out using the free body diagram. Okay? And the distance that we're covering is, again, it's going to be, so we know h over L equals sine theta. So h over sine theta is L. That's the distance that we're covering. So let's see if we can figure this out. X is 1/2 at squared. So we're going to have h over sine theta equals 1/2 g sine theta minus mu g cos theta times t squared. So it turns out the time it's going to take us to get down this inclined plane is going to be 2h g sine theta minus mu cos theta all over sine theta down here under a square root. That's the time. Now, if we want to get v, I'm going to urge you use the equation v squared equals v naught squared plus 2a times x minus x naught. I want you to try to use this to get the answer. All right. So that's the solution to our second exam, more or less. And we'll be doing a third exam before the semester's over.